Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our D programming language series. In today's lesson, we're going to continue about structuring data. Now, if you've been following this series because you're subscribed, you've been looking at some videos on structs most recently. And structs, again, are a way to aggregate multiple data types together and treat them as one new data type. So for instance, if we had a 3D coordinate that we're trying to represent with floating point values of x, y, and z, we can just put those into some point 3D struct. We've been looking at some different operations and constructors and some neat things that we can do with structs. But sometimes we just want to aggregate the data and have a collection of values. And for that, we have, again, the tuple data structure, or again, as some folks call it, the tuple. So let's go ahead and take a look at it, and we'll try to see a use case of where this might be useful. So I'm going to go ahead and take you to the deep programming web page here. Let's go to documentation, the library reference today. And again, we're being our standard library here, Phobos. And I'm going to go ahead and scroll us down here to type cons here, which is short for type construction. And again, it's part of the standard library. And the particular thing that we're going to want to look at, again, is the tuple data structure here. So let's go ahead and take a brief look at it and see what we have here. So what you're going to notice here is that it is some sort of struct in a sense. That's all it is. It's the same thing we've been working on. But I'll go ahead and show you what's a little bit different and convenient about tuples. So again, it's a way for us to structure together data. Now again, we haven't talked about templates yet in D yet, but what this is, the syntax here, is a declaration of a new specific instance of a tuple that contains an integer and a string here. So for example, maybe we have a student with their name and their ID stored as integer. And maybe we don't want to create a named struct, for instance, and we just need to be able to return a single piece of data or a new data type here, like a tuple here. So we'll go ahead and look at a few of these examples here. Now, what's interesting about tuples, and we'll do an example as shown here, is that we can index into each of these fields, such as this integer or this string, by just using the array notation. So that's something that's unique. And we can even do some neat stuff if I scroll down here and name rather than refer to just the 0th or the 1th index in the same way that we refer to the fields of a struct by name here. So we have an option to do either, and this is again just a nice utility for us as programmers to write readable code. So with that said, let's go ahead and look at some examples of where we might want to use a tuple. And I'll go ahead and just start us off with some syntax first here. So let's go ahead and first and foremost import that type constructor library here, type cons here. And let's go ahead and just create our first tuple. I'm going to kind of follow along with this example that we saw earlier here. Let me go ahead and scroll back up and find it here. Here's tuple. And let's go ahead and do something like with a point here. Okay. So what I'm going to do here is use tuple. And again, the exclamation point here is for template. Again, other languages you're used to putting the types between angled brackets, but in D we use the exclamation mark. And if we have multiple items, we use parentheses here. And let's just go ahead and create a new point here. So let's take an integer and say an integer and a point, just following along in this example here. And then what we have here is I can refer to each of these fields. So by 0, this first integer here, let's put in a value, and point here. Let's go ahead and put in value 7 here. And then let's just go ahead and write out those values here. So I'll go ahead and use 0.0. And we'll repeat that line here. There we are. And let's go ahead and run our example, make sure it works. And it works as follows here. So again, what you see here is we haven't created a struct. All we've done is sort of initiated on the fly this type here with any number of values that we have. And again, this could be useful because let's again pretend that, well, maybe we don't have a struct available. Maybe we don't want to create that particular type because it's a special use case, for instance. So let's go ahead and just see where this might be useful. Well, maybe I just want to return some point here, get coordinate here. Okay, and I'm just going to, for the sake of simplicity, return here another tuple here with let's go ahead and just set it up this way here with an int and an int, and I'll just call it result. And result at index 0 equals 7. Result at index 1 equals 8, something like that. Let's use some different numbers here. and we'll go ahead and return that result here. Okay, so now I can do something like this here. Let's just go ahead and assign our point to get the coordinate and then write out the result here. Okay, so we can see here how our return type is now able to return multiple values. And oftentimes when we first learn about structs, that is again one strategy for being able to return multiple values by again setting up a structure, creating the type, and so on. But instead with a tuple, we can just set it up and have 2 ints. Okay, so that's one example where this can be useful. Now you might argue again that you could use a struct. In fact, what I'm going to go ahead and show you here is that if I have a struct here and I just call it, let's just call it S for now. And if I give it 2 fields, X and Y, for instance, which might be reasonable things for a point to have, let's also set our point, or rather, let's go ahead and create a struct S here. Let's set the X to 100 and the Y to 200. And then let's try to see if I set my point equal to S, what happens here, okay? Because they're both things that contain 2 integers. So if I go ahead and run this here, well, I'm getting a error here. Oh, let's see if I made a mistake here on syntax. Struct S, that looks okay. Oops, that's all my fault here, just that little type error. Okay, looks like we're, oh, another error here. S, there we are. Now we're still getting some error here. And let's go ahead and see what this is here. And it's saying something like none of the overloads, let's see, of our template are callable with this struct here. Okay, so we're not able to just assign this struct to this field here. We could try to cast it explicitly or vice versa. Let's see if we can do S equal to this point, because after all, again, it's just an integer. And it says, yeah, we can't implicitly cast this expression. Now we can do a cast here, or we can try here. Cast to a type S here, our point. And that will work here. Because again, from a, however these things are structured, if I go ahead and, oops, let me go ahead and scroll up here. This is just 2 integers, and our tuple, again, is just 2 integers in both cases. So from a bit compatibility standpoint, they are effectively the same thing. Okay, but again, you always got to be careful when you're casting data or forcing it into one other structure. But that's, again, just to show you that, again, this is sort of from a pragmatic standpoint, a tuple is just similar to a struct. But we have this convenience where we can just return from some function the actual data that we need. Now, again, why is this important? Well, there's a certain power in the D programming language where if I'm able to, with these templated functions, and we can get into metaprogramming later in this series, be able to, well, effectively mix in some code and generate for the type we need at compile time and be able to return that. Which we can also actually do some of that with structs as well, mix in some struct, but it's just a really cool thing that we have the power to do with the D programming language. So there's some more advanced and cool things that we can do here. But let me go ahead and just show you a more pragmatic example, and then a few nice things that we could do with tuples, just so, again, you know what to do with them, or know some of the powers that are available. And to do this, I'm going to go to our Phobos library so we can see an example of where this is sort of pragmatic to do here. Now, let's just go ahead and search for CSV here. And let's just say that you're doing a common task like reading a comma-separated value, or a file that's maybe separated with a bunch of fields with commas or tabs or maybe end lines, however the data is formatted here. And we'll actually see in this example here where I have a name here. It looks like a first name, a last name, some value followed by a first name, a last name, and some other value here. Well, the separator between these rows in our structured data is just an end line here. Okay, so let's go ahead and just draw out this data here, right? You might have a spreadsheet or something, and it looks like it's got fields, Joe, carpenter with 300,000, and then who else did it have here? Fred, blacksmith, and I'm just writing these out very quickly with, 400,000. Now, so that's the data, each of these rows here across, okay? Just so you can see how it's structured here. Row number 1, row number 2. But again, we can see here from the code here, it's just a string, and an integer here. Okay, so that's how this particular text is being formatted. And you can just return that type here with this CSV reader. So it's a really easy thing to do here. And that's kind of a nice pattern here if you're just reading out the data. You don't have to create a whole nother struct for this, okay? You could, but again, it's just an option. Now, in this particular example, I would argue that we can use some of these other capabilities here rather than just reading from index 0 and 1 and 2 to actually name these fields here. Okay, so that we can confirm this is in fact first name, last name, and whatever this integer is. I don't know, maybe this is salary or something. So let's go ahead and just take this example here. I'm going to grab this text here and let's go ahead and add this here. Let's go ahead and add in that. Yeah, let's do this CSV reader here. So we're going to need the CSV library here. And I'm just going to go ahead and grab this text here. Let's go ahead and do that. And let's do a for each record. Yeah, we'll just go ahead and read it here. And let's make sure that we import CSV and take a look here. Okay, and let's see what they did here. They just read off the records here in this formatted string. So let's go ahead and just run this here as it is. And again, in D, we can have spaces between our formatted lines here. Let's see if I made any silly mistakes of any sort. It says Joe works as a carpenter and earns, wow, $300,000 a year. Fred works as a blacksmith and earns $400,000. Okay, so these folks are wealthy. That's great. But let's go ahead and again try to airproof this code just a little bit here. I'm just going to address this as first, last. And again, if I'm a new programmer here, I don't know what this integer is, this magic value here. I can kind of guess, but let's just go ahead and label it as salary here. Then I can update my record here to record.first, record.last, and record.salary. Okay, so I've named these fields here, and it works just the same. So that's something that I like about tuples, having that flexibility. And in general, this shouldn't cost me anything, right? As far as the compiler is concerned, this is just another way to, look up the names here, right? The compiled code, I would bet, is the same here. But again, I would argue this is kind of nice here and a nice power to have this ability to name your fields here. Now, it's actually kind of neat as well is you don't have to name these. I could get rid of this here. Maybe this is something that changes, or maybe it's data that doesn't exist here. So you can mix these things if you want. I wouldn't recommend doing that. I would probably name every field if you know what every field is. But especially when you have structured data like text here, and I think the CSV is a good example, it's kind of nice to be able to name these fields here. So anyways, just to review here and put this all together, tuples are a nice way to create a new data type on the fly here. Okay, now technically we could do this with structs, but they worked well here. We can name them or just index into the fields here without having to worry about the offsets or anything like we would with structs. Now I would still keep using structs in the example like provided here. If you just have like an X and a Y, like if you're in a game or something or a math application, right? It's worth just naming those particular points here. And you get your other stuff with structs, like if you need constructors, custom equality operators, these types of things to write the hash function or whatever, right? Then you want to use a struct and you build up that type. But for just quick collections of data, tuple is not a bad thing to use, and it's effectively doing the same job. All right, folks. So with that said, I hope you're enjoying this series. If you are, you can track your progress on courses.msha.io. It's free to sign up for the D language series right now, so you can go ahead and check that out. And I hope you found this a useful lesson. I just always love finding these useful little utilities in the D programming language. The standard library is quite rich with these different utilities, and we'll be exploring them in these series, so make sure you check those out. All right, folks, with that said, I'll look forward to seeing you in the next one.